Now, they want you to define the terms mole and Avogadros constant. This question is from Quick Review B, page 32. Okay, so define the terms mole and Avogadros constant. So, what does 1 mole means? Alright, so 1 mole of any substance is the amount of substance that contains Na, okay, the small a, Avogadros constant, Na, number of particles. So this Avogadros number, which is Na, contain 6.02 times 10 power of 23 units. Alright, so this is how we define 1 mole and Avogadros constant. Okay, so relate the number of moles of the substance to the number of particles in it. Now let's go to the question. Relate the number of moles of a substance to the number of particles in it. Number of moles, small m. Number of particles, big M. Okay, so what is their relationship? The relationship is this. You have big N. This one is what we call number of particles. Alright, so this one N and this one is Na. So this is the number of mole. So the relationship is directly proportional. So this one is directly proportional with this. In language, this is called N is directly proportional with number of mole. Right? So with small n. So let's go to the next question. The next one, 2. How many moles of bromine gas Br2 contains 1.505 times 10 power of 24 molecules of bromine gas? So they are asking how many moles, how many small m, is like how many chemistry dozen, and they also given you the actual number of molecules of bromine gas, 1.505 times 10 power 24. That one is big N. Right? So let's look here and find out. So if you want to get this, you must use actual over standard. Okay, they ask for the number of mole of the bromine molecule. Alright, so they tell us that it has 1.505 10 power 24 molecules and 6.02 times 10 power 24, no, 23, sorry. So a few calculation will be this one, you get 10, so you get 15.05 divided by 6.02. Your final answer in the unit of mole should be 2.5. Okay, you should have 2.5 mole of bromine. Okay, 2.5 moles. It's like 2.5 dozens. Alright, so let's move on with the next question. Number 3. Calcium is needed for the formation of bones and teeth. How many calcium ions are there in a serving of cereal that contains 0.007 moles of calcium ions? Okay, very straightforward. You just find the number of ions, calcium ions. Okay, or to be more general, just ions. So this one, just number of mole times Avogadros constant 0.007 times 6.02 times 10 power 23. So your final answer should be 4.21 times 10 power of 21. Alright? 4.21 times 10 power of 21 ions, or specifically calcium ions. Let's move on. Number 4. Given 1 mole of hydrogen gas H2 and 0.7 moles of sulfur dioxide, which one has more atoms? Give your reason. Okay, let's put the information forward. 1 mole of hydrogen molecules and then 0.7 mole of sulfur dioxide. Now the key question is, who has greater number of atoms? They are not asking for greater number of molecules. Okay, so they ask which one has more atoms. Now let's investigate this. This one is HH in a capsule. This one is SOO in a capsule. Okay, so the number of atoms would be 2N and A. Alright, so 2 times 1. Where do I get the 1 from? 1 mole. So I keep the answer as 2Na. Where do I get the 2 from? 2 atoms. Now let's check out this one. Number of atoms for sulfur dioxide. Why do I put 3? Because it has 3 atoms, N and A. Now I multiply the number of moles, 0.7. Why 0.7? Because it is given the number of mole of sulfur dioxide is 0.7. Okay, so you have 2.1 Na. Now I want you to compare these two. 2 Na versus 2.1 Na. Either way, when we whether we calculate the Na 2 times 6.02 or not, we can compare straight away. Who is bigger? Sulfur dioxide has more atoms. Okay, no doubt about it, because you can just use 2.1 times 6.02 times 10 power 23. In this stage, you don't have to compare. You can see it. 2.1 is bigger than 2. Alright. Now let's move on to question number 5. Question number 5. What is the difference between 1 mole of oxygen atoms and 1 mole of oxygen molecules? Okay. So what's the difference of 1 mole of this and 1 mole of that? Okay, this is atom, this is molecule. Okay, so 1 mole will have 6.02 times 10 power 23 sets of molecules, but 1 mole of this will have 6.02 times 10 power 23 sets of atoms. Okay, in terms of their number, they have the same number, but it's the types of stuff that they have. Okay, the first one on top is more like a molecule. It's like asking how many pairs of husband and wife in Malaysia. Another one is asking how many single in Malaysia. Okay, because single and or husband and wife, they are all humans. Okay, so the only difference is the types. The number could be the same, but the concept is different.